Hello, my name is David Thomas. I'm a student at Mass Bay Community College. I'm taking pre-calculus as a prerequisite for calculus. For my project, I chose to do graphs of trigonometric equations because it sounded kind of challenging and I liked the idea of that. So without further ado, here's what I've got. So here we have the general sine equation, and that is y equals a sine of b times x minus c plus d. And each of the different variables has a different effect on the transformations of the sine equation. Now, the regular sine equation, y equals sine of x, starts at the origin and repeats itself every interval of 2 pi. The absolute value of a affects the amplitude, so if a is greater than 1, the amplitude increases. However, if a is between 1 and 0, the amplitude decreases. Similarly, the absolute value of b affects the period, frequency of the period rather. So if b is greater than 1, the period increases, the frequency increases. And if b is between 1 and 0, the frequency decreases. Now, c affects the horizontal shift. So if c is greater than 0, the graph shifts to the right, and if c is less than 0, the graph shifts to the left. But keep in mind that the initial equation calls for b times x minus c, so you need to flip the plus and minuses there. D affects the vertical shift or the midline, so if d is greater than, if d is positive, you shift up that many units. If d is negative, you shift down that many units. And lastly, a negative sign equation will flip the entire thing along the x-axis. Now here we have the general cosine equation, which is effectively the same thing as the sine equation. Y equals a cosine of b times x minus c plus d. And it's nearly identical. The big difference is that the cosine equation starts on the point 0, 1. And then we go into the different variables. Once again, absolute value of a affects the amplitude. So if a is greater than 1, the amplitude increases. If a is between 1 and 0, the amplitude decreases. Similarly with the absolute value of b, if b is greater than 1, the frequency increases. If b is between 1 and 0, the frequency decreases. C again is the horizontal shift. So if c is greater than 0, it shifts to the right. If c is less than 0, the graph shifts to the left. And again, just bear in mind that the initial equation calls for b times x minus c. D again affects the vertical shift. So if d is positive, the midline goes with it, and if d is negative, the midline goes with that. So here you see the midline going up and down 2 units. And again, a negative cosine equation will reflect it along the x-axis. Here we have the general tangent equation, which is very similar to the general sine and cosine equations with some differences. The tangent equation is the ratio of the sine over the cosine equations. Now for the equation y equals tan of x, the function repeats itself in intervals of pi, and there are vertical asymptotes shown here at plus or minus pi over 2 and so on. For the absolute value of a, instead of amplitude, we have stretch and compression. If a is greater than 1, the graph is stretched, and if a is between 1 and 0, the graph is compressed. And similarly, for the absolute value of b, if b is greater than 1, the period increases, and if b is between 1 and 0, the period decreases. Once again, for c, the ratio of c to b, in this case, b is going to be 1. So if c is greater than 0, we shift to the right. And if c is less than 0, we shift to the left. And again, we have to switch the operators here because the original tangent equation is a tan of, bx minus c. So you need to shift the operators. And then we have, once again, d is the midline. And if d is plus 2, you go up 2. If d is minus 2, you go down 2. And lastly, we have if y equals negative tan of x, we reflect along the x-axis.